All right, so as you can see here, the last part of our tour through the basics of geometry here is just ensuring that you understand how to write these sorts of proofs here. So we're going to take a look at problem number 2 as an example here. I'd like you to try this one out. So do this problem on your own first, and then we're going to look at it, and then we'll do a video proof for this here. For the rest, you can kind of just do that on your own as additional practice, and for the homework, you will be asked to complete the rest of this here using the basic theorems. Okay, so we know what's going on here. We have AC bisects BAD here. So now we can go ahead and plan this out. We see that AC bisects BAD. This means in this situation here, BAD is like this. So that means our two angles here happen to be congruent. So angle 1 is congruent to angle 3 here. We kind of have that. And then we have these sorts of things here. So let's go ahead and write out what's happening. Okay, so I'm going to go ahead and write out my proof here. Now I'm going to write this a little bit small, but I hope you can see this relatively well. So note that in the first thing that we did here was we utilized the fact that AC bisects BAD. So I'm going to go ahead and introduce that. That's going to be my first statement here. That's a given piece of information here. Now we know that because it's an angle bisector, it splits an angle into two congruent pieces. So I can say angle 1 is now congruent to angle 3 here. And that's going to be my definition of an angle bisector from step 1. So again, notice how I treat this as if this were still a Boolean logic proof here. We're going to explain everything, we're going to write everything out, we're going to explain why that's the case here. So now we want to see where we can go with this here. We were told, well, the other two pieces of information, we're told that angle 1 is supplementary to angle 2 and 3 is supplementary to 4. And we have 1 is supplementary to 3 here. So again, now we have to consider, wait a minute, this feels a lot like one of our theorems before. Because 1 and 3 are essentially the same here, the congruent angles here, we've got two angles that are supplementary to congruent angles, so that means they themselves have to be congruent here. So this, again, is the power of using a theorem here. If you can find a theorem that fits in a specific situation, you can use it without having to go through everything again. Otherwise, you probably would have to sort of, use these, convert these to the fact that they sum to 180, and then 1 equals angle 1 has the same measure as angle 3, substitute them, subtract, and all this other stuff. We can save ourselves a lot of time by simply utilizing the proper theorem here. So now, in order to use the proper theorem, I have to introduce the next two givens. And since these next two givens are going to be used with the theorem that I'm going to cite in step 4, I'm going to put these two theorems together. Sorry, these two statements, these two givens together. So we can say angle 1 is supplementary to angle 2, and angle 3 is supplementary to angle 4. And that's also given to us here, right? Now let's move on here. Now we notice that the stage is set for us to use our particular theorem here. 2 and 3 are set up in this situation here. So now, because 1 and 3 are congruent, and 2 is supplementary to 1, 4 is supplementary to 3, we can now claim that angle 2 is congruent to angle 4 here. Because, remember, our theorem tells us that if two angles are supplementary to congruent angles, then the two angles are congruent. So unfortunately, there is no real shortcut here when you're dealing with theorems. You have to cite your theorems in full. If there will be specific theorems in the future that will have official names, and then you can cite those by name. It's kind of like how we cite laws by name here, but unfortunately, these are relatively minor theorems on the totem pole, so we can't really cite them by a name. They don't have a name here, so we're just going to simply write it out. Okay. Now we're almost done here because we want to get 2's congruent to 5. Now we look at our picture here. We now have 2 and 4 congruent, so I can mark that off here. So I'm going to use these here. I'm actually going to use 2 dots here. As an alternative to using loops to measure to show the pairs of angles are congruent, I can use matching pairs of dots. So up here I can use 1 dot here, and I can use 2 dot here, okay, and so on and so forth. That might make things a little easier to read than just nested loops. So now we note that in this situation here, what we have is two lines that intersect here, and therefore angle 4 and angle 5 are congruent. So we can go ahead and mention that here. So the next portion of our proof is going to mention that. So we can say angle 4 is congruent to angle 5 here, and this is the fact that vertical angles are congruent. Right, so that's from the picture here. We actually don't need to worry about a step for this. This comes to us directly from the picture. Now, technically, if we really wanted to be sure about this, we should have stated that, A, D, and CD are lines that intersect at D. And then you can use that as, the step that justifies your vertical angles being congruent here. Because this picture, there's nothing really sort of like, there's nothing here in the picture to sort of mess around with you. Don't worry too much about it here. But, in the future, you will see these sorts of things, and please include those givens. Okay, so now vertical angle is congruent here, and now we have 2 is congruent to 4, and 4 is congruent to 5 here. So we can now finish it off and get angle 2 is congruent to angle 5 here. Now, in this situation, this looks a lot like our substitution postulate that we did before, but a word of warning. Remember that the substitution postulate works with equality, and we don't have any equalities here. All these are congruences. So because we have congruences, we can't use the substitution postulate. Instead, we have A is associated with B, B is associated with C, so A is associated with C. That looks a lot like a transitive property, and we're going to mention that here. There's going to be our transitive property, and that's going to be from steps 4 and 5 here. Notice how in this situation here, we're going to be using the transitive property because these are not congruences here. These are not equalities here. These are congruences. So the only time you can use substitution postulate is when you see equalities. If you don't see equalities, you can't use it, and instead just use the transitive property. The transitive property being sort of like a bigger version of the substitution postulate, you can actually use in many more places than you can the substitution postulate.